Hello everyone, let's continue working on this practice project. So now we want to draw a box plot. So then we're going to go to Graphs, Lexi Dialogs, and then select Box Plot. And we need to select Simple and Summaries of Separate Variables. Click on Define. If your weight locates here on the left side, then drag your weight to the boxes represent, click on OK. Then you can see the box plot provided by the software. Then we're going to double click on this box plot, get into the chart editor, click on this icon to make the box plot horizontal. And then we always want to delete these numbers because those represent the first and the 13th order number, which is confusing. We want to right click on any of the given numbers and then click on delete, close. Then those are all layers with the corresponding values located on the numerical scale. So we have 278.8 and then 129.2 here as the outliers. Click on X, and then we have the complete box plot. Okay, can minimize that, and then let's look at what else we can do on top of this data. So we can also report the mean and standard deviation of the data set. So we're going to go to Analyze, Descriptive Statistics, Frequencies. Make sure your weight is under the Variables window. Click on Statistics. Make sure you select your mean, standard, and deviation so that SPSS is going to report those. Click on Continue, click on OK. Then you have the mean and standard deviation reported. So with those, we can actually calculate the z-scores for the weight data column, all the z-scores for corresponding observations there. And then we're going to select transform compute variable. And then we're going to just type in z-score, represent, we're going to generate another column, store all the z-scores. And then the numeric expression going to be double click, we need open and close parentheses and double click on weight, meaning that we want to use the weight column as our x, and minus x bar, which is the mean. So we have x bar equals 177.185. 177.185, and then divided by the standard deviation, 36.5186. And then click on OK. You have the z-score reported. So we go to variable view. We can align that and then show more decimals, the z-score. And again, if we look at the value 278.8, that's 2.78 standard deviations above the mean. And this one, 29.2, that's 1.314 standard deviations below the mean. That's why box plot report those two values as outliers. Okay, and then for the next part, let's talk about some normal probabilities calculation. So let's generate another data window so that we can type in some values there. So for example, we want to calculate the probability of x smaller than 6. Then we're also given x from a normal distribution with mean 4 and standard deviation 5. So the variance is 5 squared. So what's that probability? How can we do that? So then we're gonna just type in the value that we want to calculate, which is 6. Double click, we can change that to z, that x, representing that's for a non-standard normal distribution. So then we can use the function to calculate the probability. So again, transform, compute variable. So now we want to calculate the probability, which is cumulative probability, for probability of x smaller than 6. So that's how we gonna name this the column storing the probability calculation. And then we're gonna go to the function group, find the CDF of normal. So first we click on CDF from this function group, and then we can see all the functions we can choose. We're gonna choose CDF dot normal. Double click on that to get that into the numerical expression. And then the first question mark is highlighted. Double click on X, replace that first question mark. And then for the second one, we type in the mean, which is 4 for the question. And then the standard deviation, which is 5 here. So then you can click on OK. And then the probability of X smaller than 6 is then given here. So if you want to show 4 decimal places and a line at the center, you can do that under the variable view. So for probability of x smaller than 6, the cumulative probability, which is probability of x smaller than 6, equals 0.6554. So we can verify that by generate another column storing the z-scores. Because if we want to use table to calculate that, we want to transfer x to z, right? So that's 6 minus 4 over 5. Then we want to check 0.4. So then we just type 0.4 here, and then rename that as z. Then we want to generate another column storing the probability. If the calculation is correct, these two values are going to be the same. So then we're going to click on transform, compute variable. So we want to look at the standard normal, right? So we want to generate another column, give a variable name cumulative probability. That's for standard normal. And then for the numeric expression, it's still CDF.normal. And then the first question mark, we're going to change that to Z. So highlight and then double click on Z. And then for the second one, we want to type 0 and 1, stating that standard normal means 0 and variance 1. Click on OK. And then double click on the variable name to show 4 decimals, align at the center. Go back to data view. And now we can see those two probabilities are the same. That tells us what? If we want to see probability of x smaller than 6, it's the same as probability of z smaller than 0.4, and that's how we use the software to calculate that. So another thing is when we know the probability, how can we calculate the z? So then we're gonna go to transform, compute variable, and then want to generate another column storing the z for backwards checking, right? So we first check the z, and then if we have a non-standard normal, how can we check x? We're going to do the standard normal first. So z for the backwards checking, given the probability, which is 0.6554, we know the answer should be 0.4, but let's do it using the software, see whether we got that number. So the function we're going to use is the inverse df. So let's clear that numerical expression first, click on inverse df, and then we want IDF normal, right? So this is the one, double click to get the function into numeric expression. And then we are given the probability, right, for the standard one. So the first question mark should be replaced by this one. So double click to get that, replace the first question mark. And then for second one, since we're checking the standard normal table, so mean 0, variance 1, or standard deviation 1. Click on OK. So we got 0.4. So that's calculated based on this probability, which is correct, right? So what if we direct want to check the non-standard normal distribution? So given x follows normal 4 and 5 squared, probability of x smaller than a equals 0.6554. What is x? What is the a, right? So then we're gonna go to compute variable again, and then the z backward, and for the non-standard normal, so we put an x here. So we're gonna see that variable here, and then it's still the inverse, right? So however, we want to type in this probability. So highlight the first one, probability for the non-standard normal, right? And then the normal is not standard anymore. So 4, 5. So what we should see? We should see 6, right? Click on OK. And that 6 is reported. And it's the same. So either way, right? Regular checking or backwards checking, use SP as S. Okay, so that's pretty much all we have for this practice project. Thanks for watching.